Today we are going to talk about the lab A, which is distance versus time of an object rolling down in an inclined plane. This is one of the lab corresponds to the special lab report. In this experiment, we want to determine the relationship between distance the car is traveling on an inclined plane and the time take to move that distance. The materials we are going to use in this experiment will be the inclined plane, the mirror stick, the stopwatch, the car, and the stopper. In this experiment, distance and times will be the variables, will be the what we are going to measure. However, for example, the mass of the car we will keep constant. The inclination of the plane, this is another quantity we are going to keep constant. That two quantities will be the same value through all the experiment. We want to see if the relation between distance and time for the motion of the car in an inclined plane follow the Aristotle model or the Galileo's model. Remember, in case of the Aristotle model, in this case, we consider the velocity constant. This we can apply this one if the velocity of the object is constant. If the velocity is constant, the acceleration must be zero because there is no change in velocity. And then we can describe the motion of that object using this equation. If the object is moving at constant acceleration, then we can apply this model. And the equation that describes the relation between distance and time is the equation we have right here. Then at the end, we want to see if the hypothesis of this experiment will be based on these two different models. If we can explain the motion of the car based on Aristotle model, constant velocity, or Galileo models, which is constant acceleration. In this slide, we had part of the table you had to report. You had to report in the lab. First, you had to write the title of the table, and then you had to complete the table. In the first column, we had the distance, and the distance is in centimeters. This is why we had two significant digits, because we want to report all the units in SI system. This is why the next column we had distance, but in this case in meters. And you had to convert these centimeters into meters. And remember, we want to keep the same number of significant digits. Also, we had to measure, we will measure the time for each distance 3 different times. There's 3 trials we will take for each distance. And then we will write the time in each case in these columns. And finally, you had to calculate the average time. Then you had to add these 3 times and divide by the I think this is all you had to know about the table. Remember, this is only part of the table. Yes. Now we are going to talk about the procedure. Then how we are going to measure the time that the car traveled the 10 centimeters. The first thing is we will use the mirror stick, and we will use the front of the car as reference. Then we will try our best to put the car gas on 10, the front of the car gas on 10, and then we will measure the time that takes to the car to travel this 10 centimeters. Then we will start, and you can see the initial velocity of the car is 0. The car is at rest. Yes, and we will we will release the car without pushing, without doing any force. Yes, just we release the car from initial velocity equals 0. And we start. And then this is the first trial. This is the time for the first trial for a distance of 10 centimeters. And we will write this one in table 1. Yes. And we will repeat the same procedure in the second trial. And then in this case was 29.29 seconds. And another thing I want to tell here is we can measure at to hundredth of a second. You can see we can measure just 2 decimal places of a second. And now we will do the same thing. And then we will collect the data for the last trial for the distance equals to 10 centimeters. And then we will write this one in table 1. And we will do exactly the same procedure for the other distances. And just to review again the procedure, remember we will try to use the reference, the front of the car as reference. This is why this must be just on 50. And then starting from velocity equals 0. Yes, we don't want to push the car. We don't want to give any extra force to the car. Just release the car. Then, and we will measure the time for, in this case, for 50 centimeters. And the time was 0.92 seconds. And we will do the same in the second trial. And the same for the third trial. And we will collect this data in the table 1. And we will do the same thing for the other distances, and the same we did for 110 centimeters. Yes, we will starting from initial velocity 0 without put any extra force. Just we release the car. And then we measure the time. Yes, we measure the time. In this case, the time was 1.37 seconds. And you can see the maximum decimal places we can measure using the stopwatch is 2 decimal places. And we will do the same for the second trial. And we will get the second time for 110 centimeters. Is 1.40 seconds, and we will do the same for the third trial. In this case was 1.36 seconds. And we will collect this data in the table 1, and we will do the same for 120 centimeters. And after we collect this data, the next thing we had to do is we need to complete the table, and then we will analyze the data. Then we need to check if we can with what model we can explain better the motion of the car. If we can explain using the Aristotle model or the Galileo's model. Then the first thing, after you complete the table, then I suggest you to answer the question in the lab sheet, because this will help you to get all the information you need to complete all the section of the special lab report. And because we want to know if we can explain the motion of the car using the Aristotle model, if the distance is proportional to the time, then the first graph we want to plot is distance versus time. Then after you complete this graph, you will answer the questions 1 and 2 in the lab sheet. The next graph we want to complete is the distance versus time squared. Why? Because we want to see if we can explain the motion of the car using the Galileo's model. Then because you need to know the time squared, then you need to add this column in table 1. You need to add this column to the table 1. Then once you complete the graph, you will respond the questions for number 4 and number 5 in the lab sheet. Then the next thing we want to do, we want to analyze this equation, and this is why you want to compare your experimental equation with your theoretical equation. What is the theoretical equation in case of the Galileo's model? Is this one. Yes, we already discussed that. Then comparing these two equations, you will get the experimental acceleration of the car, if we can explain the motion of the car using that model. Because we want to compare always our experimental values with some true values or some theoretical values, then it's good to try to find that theoretical values, because that is telling how well we did the experiment. Then for find the theoretical acceleration, I did this experiment, but in this case, instead of using the stopwatch, I use the sensors. I use the sensors to measure the time. And in this case, we are going to eliminate the reaction time problem, because when we are using the stopwatch, it depends how quick you can react when just the car starts and you start the stopwatch at the same time. And in this case, you can see here in this graph on top, these are the sensors, and this will be activate once this flag is here in this car. Activate the sensors, and when this flag pass through the sensors, will be activate, and then the time will be start running. Then this is one thing, we eliminate the reaction time problem when we use sensors. But the other thing you can see here is, in this case, we can measure at 2,000th of a second. We can measure 1, 2, 3, 4 decimal places instead of just 2 we are measuring in case of the stopwatch. Then this is why we can consider the acceleration we calculate from this experiment, we can consider as theoretical acceleration. That's because of the condition in which we are doing the experiment. Also, here I complete this table, and you can see here, in the case of the time, we had 4 decimal places in each measure. Yes. And this is why also we had 4 decimal places in case of the average time. And also because I graph the time, the square average time, then this is why also I need to add this column to the table. Then once I complete the table, I graph the distance versus time and distance square time, and these are the graph I got. And then analyzing this data, I got the theoretical acceleration was 1.068 meters per second squared. Then once you calculate this acceleration, once you calculate the experimental acceleration, then you can compare this with this theoretical equation, if we can explain the motion of the car by Galileo's model. Then at the end, you had to answer if the motion of the car was better explained by Galileo's model or Aristotle's model. Then also you had to say if your hypothesis was valid or not. And remember, this is based on, these are the idea of the Aristotle model. If the velocity is constant, we can explain the motion of that object using this equation. We can describe the motion using this equation. But if the object moving at constant acceleration, then we can describe better the motion of the object using this equation. Then here, I don't want you to turn in the lab sheet in this case. I want you to use that information you have in the lab sheet to complete the special lab report. And the first thing I would like you to do to complete the special lab report is read the special lab report guidelines document that will be under lab 8. And you had in this document, I explained what you had to complete in each section. And you had to complete each section, as you had to complete the cover sheet, the abstract, the introduction, hypothesis, all these different sections. And if you had any question, always you can email me. If you write that section and you are not sure, you can email me what you already write, and then I can help you to tell if what you include in that section is correct. One important thing when we are writing reports in science is we use just third person and past tense to write lab reports. This means you should not use personal pronouns like I or we. And all procedures you use in your study should be writing about as if they happened in the past. Then what example, what you should don't, how you should don't write in this way. We found is not correct. Our group, I found is not right. I don't want to see these three words in the lab report. We, our group, I. Yes. We found the spring constant K is the slope. No. Our group found the spring constant K is the slope, 3.02 Newton meters. It's not correct. I found the spring constant K is the slope, 3.02 Newtons meter. It's not correct. And how we can fix that? For example, you can write like that. The spring constant K was found from the slope to be 3.02 Newtons per meter. Then this is one way you can write the same thing. The other way, which is simple, the spring constant K is the slope, 3.02 Newtons per meter. Then this is all I had to discuss in this. And always you can email me if you had any doubt about how to write the lab report, especially because this is the first lab report we are going to write in the course.